Okay, so okay, today's Tuesday, June 8th, and this is our first discussion session. Unfortunately, nobody is here. I guess I will have just since right now time is 5 o'clock. Well, actually 5:07 right now. I will just run it by myself and feel free to ask me question if you go over this when you go over this video. If you have any question, just feel free to to. So what are we going to do today? First of all, is to go over the codes. The answer key of the first problem set, and the second thing is that to give you some of the hint on the problem set number 2, especially on the question number 4. All right, so let's get started. Oh, and first of all, let me share my screen with you that where you could find the answer key. Hold on a second. Share my screen. Okay, so if you go to your Blackboard, and when you click assignment, so you're supposed to see a bunch of the folder here and click problem set 1. So you will be able to see the answer key I just post here. So basically that's what we are going to do for today. All right, so you could go over this by yourself and I will do it right now. Okay. Uh, so share my screen. Share my screen. So what is the first question? Um, the first question we have here is to describe which R and RStudio version that you have installed, right? And second part is that show your current working directory, and then what package are you installed so far, and then just using one of the default dataset to um, play around with the plot and try to use the time series function in R to make your data into time series classic. Okay, so let's do it. Um, so first of all, some of you using the Word or using other ways to type up your homework. I think it's okay, but one of the side product of this course is that you could get used to R and maybe R Markdown. So I just feeling that it's a good timing for you guys to learn how to use R Markdown. Okay, so basically this is um, um, quite easy. Quite easy. You could Google R Markdown online, and you will see a lot of the resources. Actually, you could go over their document and see how do you build R Markdown document. It's quite useful, and it's interactive. So I will highly recommend you to do so. Okay, so this is my R Markdown document for the first homework assignment. So after I need it, so if I press need, I will have another document coming out like this, right? So R is doing the job for me, and you will find another document in your working directory, like the answer key I post online. So we don't have to wait it because I already downloaded. So why don't we just getting started? There you go. So first of all, you need to know what's the version. Uh, you need to know what's the version of the R you are using, right? So now you are using what kind of the version of the R. So R is the software that they will continuously be updated. So the code that you need to use is this. So it's R version string, right? So two ways you could run this one. So you could go to the prompt and just type R version R string, and then it will echo you the result. So now you can see what version of the R you are using. Okay, another thing is that what kind of the R version you are using right now. If you want to downgrade a little bit, how do you do so? So go to tools, and you could see there's a global option here. And click it, and you could see if you install all kind of the version of the R, you could change it by clicking this button, and you will see the core of the R here by using a different version, and you can just click one of them. All right, so usually they will release the stable version online. So the latest one's supposed to be like quite stable. So you should keep it updated. If your interface looks a little bit from me, maybe that's because you haven't updated to the latest version. But it's up to you. Some people just like to be the first one to get the newest version, and some people just don't. Okay, so that basically it's the first question. And what about the R Studio? So R and R Studio are two things, right? So R is the software that help us to run the statistical package, like statistical programming behind the scene. And R Studio is the interface for the uh, for us, right? So it's called IDE for R, and that's just like this environment. So as you could see, this is the script. Okay, so here is my R Markdown file, and here it's called console. So everything you talk to R will be replied here. So for example, if you want to go over the easiest calculation, for example, 1 plus 1, you ask R, R will echo you back a number. And so is the things. For example, if you're using 1 divided by 2, you will get 0.5. And in the right side section, it's called a data section. So basically, this is where you see all the data, right? So here I have another working project ongoing right now. So this is my data. But if you right-click then, okay, you actually could see what the data looks like um, in the right-hand side, right? Okay, and lastly, the lower right section here, it's your packages, your files, and plot. So this is basically the outcomes that will show. It's here, okay? So that is the environment of the RStudio. So how do you make sure like which RStudio version you are using in? So if you are using the Windows system as I do right now, you could just click about RStudio, right? So click help and click about RStudio here, and you will see the version. All right, so basically that's your question. Question number one. Question number two, to find out your current working directory. Okay, so this is important. So sometimes people, the first beginner, the beginners, they use the R, cannot find the working directory. So the easiest way to find it out is to use get WD function. Okay, so WD stands for working directory. So get working directly intuitively is what? It just get the path of the working directory, right? So then right click it and run it. We will get uh, you will get like this. So it will show you the path of the working directory that you are looking at right now. What about changing the working directory? You need to type set wd, right? So set wd to claim the working directory that you point to let R know which folders you are working right now. Okay, so that will be another tips here. So basically, this is my working directory. So I put everything I download in this folder in my Windows desktop. So as you can see, this is I put it on desktop. You right click it, you will see my R Markdown, which is the file I right now looking at. Oh, no, sorry, yeah, R Markdown. You can see the R Markdown file. So RMD stands for the R Markdown file. It's in this working directory, right? And then finally, that probably is it for the question number 2 in problem set 1. Okay, and then the question also asks you to show the packages that you install on R. So there are lots of ways to do so. So basically, if you just go to the your R Studio and click this one, you could see the top 3 packages here. So you could just copy and paste, or just simply type down their name, or just print screen and then let me know. Or the easiest way in R is to use the command. It's called install package, right? So if you are familiar with R, you probably know that R has a lot of the packages it's made by the users, right? And the way to install the new packages is to use this function, install packages. But now if we're just looking at what kind of packages I have, I could just simply type this function. So they will list out a whole packages, like what kind of a packages I have right now in my R. But the question asks me, right? The question asks me, just simply show the first 3. Okay, so the column first 3. That's it. So that will be the top 3 packages I ask R to show me. So the top 3 packages I have here is called anytime, ask task, assert that, right? And there are the information. So here, the column is called the variables, right? So anytime is a packages, so this packaging called anytime, and then the second column, it's his variable. It's called path, and it's the version and priority and so on, right? What if you just want to clean? You just want to have a clean version of the name. So you see the name is in the first column, right? So you basically just type like this, and you will just see that 3 packages names list out. Okay, so basically you have a lot of way to answer this question. Print screen, let me know, give me the direction, let me know, or just simply type down all the packages you have on your R. Okay, and the next one is to check. Let's see. Nope. The next one is to check. I'm trying to find a question. Hold on. Okay, here we go. So the next one is to type this command in R, right? And familiarize with the data. Provide a brief description of the data, including the time span. Okay, time span means the beginning of the data, end of the data, frequency, and class. And produce a series time series plot of this series and share your code. Okay, so let's see how do we do this. So first of all, we have to follow the instruction, right? So follow the instruction. First of all, we need to type a question mark along with the Johnson Johnson. Okay, so question mark Johnson Johnson, and this is what you see. So you will see the documentation of this um, packages or this program. It's called Johnson and Johnson. Okay, and then what we need to do, we need to plot the data inside, right? So we need to require two of the packages that we needed here. So it's those two. So basically, you just follow the instruction in the document, okay? And as you can see here, you actually already be able to see what kind of a data they include in this packages. So you'll see here, 9060, 9061, 9062, and there's quarter one, quarter two, quarter three, quarter four, right? So this, like very straightforward, it's time series data, right? Okay, so um, that's renamed it. So, oh, I actually already run all of them. Sorry, I should use, I should run, I should go over line by line. But now, okay, since I already run it, okay. So let's see. This is to given the name, right? So this is to given the name of the data set. So original data set is called Cap J Johnson Johnson, right? So it's Cap, but I feel using non-capitals notation is easier for me, so I change it to small Johnson and Johnson. And of course, you could use another way. For example, if you use JJ, you will get the same thing, and then you will have a time series data called JJ. All right, and then plot Johnson and Johnson. Okay, so this one will give you what? Particularly, this one will give you this graph, right? Some of you using plot TS, it's a good idea too. Okay, but it doesn't matter. Both of you could use. All right, and now we need to find the time span of the data. A lot of way you could do so. One way is just simply just type Johnson Johnson, right? And you will see this on your prompt, on your console. Or you could just type print Johnson Johnson or using print function, right? So print the name of your data. You will get the same thing. All right, and how do you find out the span of the data? It's important for us in the time series context. So start Johnson Johnson will be a good idea. So you will see 1960 month is equal to 1. What does it mean? It means it's January 1960, right? What about end Johnson Johnson? Okay, so intuitively this will give you what? The end of the time for in in this data set, right? So now you could easily know the time span. It started from January 1960 to December 1980. And what about the frequency? Now, R actually already showed you this is really neat data set. The frequency is equal to 4. So that means what? That means every 4 data, they have a cycle. And then the fifth one will gonna be the similar uh, period of the first one, right? So basically, in our plain English, how we interpret that? We interpret this as a season, right? So it should be like first quarter, second quarter, or the season, because we define season as 3 months. So 1 year is supposed to have 4 seasons or 4 quarters. That will be it. So the last one is a little bit tricky uh, for the beginners, but actually not really. So let's see, transform the Johnson Johnson data into natural log. Okay, so key term is natural log here. Some of you using natural, not using natural log. So in R, anything, if you type log something, so for example, let's say, um, if I have 10, right? So 10 is a number. If I just log 10, what do I get? I get 2.30. Okay, so what does it mean? It means that this log is actually natural log. So this is not a log that based on 10. Okay, so this is important. Some of the students use this function. That will be a little bit different, right? Even though you take the log, but your base of the log is different, your value will be different. And in economics, we usually using the natural log. It's because of what? If you take the derivative, if you take the first derivation of the natural log function, you will get the growth rate, right? So now you probably realize why we need to take the natural log as a uh, why we need to take the natural log, why this exercise asks us to do so. It's because we are always curious about a series growth rate, right? So what the code looks like? Let me see. Um, okay, so basically transform the data you need to use. Just given this named it as log Johnson Johnson. It's too long for me, so I call it log JJ. And this is just using the log function. Okay, so let's see. This is my original data set looks like, right? So you could see Johnson Johnson looks like this. However, if I take log, that will become something like this, right? So if the real number is below 2.15, when you take the natural log, there will become a negative. That will become a negative number, right? The outcome will be a negative number. So that basically is it. So I have a series. It's called log JJ, okay, and it's this. It's this right now. So I try to plot it. So basically, I can use the same idea. Okay, what about compare them? Okay, so compare, you need to make the graph to stack with each other, right? So this is the code that you need. So I think it's parallel here, and merge. I don't know. So this is just the code to stack the stack two graph here. So once you press this, I will make your first graph in the top, okay, and make your second graph in the like this. You will have a comparison look like this. Okay, but this is not so easy to see, right? You already know that the magnitude is a little bit different and the trend is a little bit different. But what about to overlay them? Okay, so if I want to overlay them, this is the um, sorry, this is the code that I should run. So this one, I should run this one. So to make the graph layout become one, and then this one. So I still using a function of the TS plot, right? So TS plot, and the first series I want to know is log JJ, and the second series I want to know is the original function. And here it's just the parameters that using this ts.plot function. I could order them like the first series I'm going to draw it in a red line. Second one I'm going to draw it in a blue line, and I caption it as a comparison. Okay, and that will be the result. So that will be easier for me to take a look what kind of the log transformation do to my original data, right? Okay, so that basically it's the first question. So since there's nobody here, uh, we probably won't stop at it. We don't need to stop, but we can continue for the question, right? I guess. Okay, so problem 2, you need to use the data from the textbook. It's Coverwet and Metcalf, this textbook, to use the data from section 1.4 explained to complete this exercise. So basically, you need to do this exercise. Also, you need to explain justify the choice of the models that you use in your analysis. The good thing is I already prescribed this question for you. So let's see what this question asks you to do. Come on, Windows. No, yeah, no. What about seeing this one? Okay, that's better. No. Okay, carry out the following exploratory time series in our produce a time plot of the data, plot aggregate annual series, and box plot that summary the observed values of each season, okay, and comment on the plot. And the second one is decompose it. Okay, so what do we first have to do? We need to load the data, right? So load the data, basically, you need to set your working directory first. So of course, this will be totally different from yours because you are not using one computer and you have your own path, right? And then find the data, like, so where is it? Like if you go back to my folder PS1, there's a called CBE data, and this is chocolate, beer, and forget what the other goods production. All right, then you could read it. Okay, so this is what you get. So after you type this in the prompt, okay, first of all you need to set your working directory to where the data is in, right? Now you tell R to look into the folder in the PS1, and then you tell him to load the data. Okay, and this is what your data looks like. Okay, so you will have chocolate, beer, and electronic something. Okay, so 3 of the variables, it looks like this. Okay, and you could just choose either of them, like you don't have to do 3 of them. I know some of the students are very diligent. They run 3 of the series. You could just choose one of them. Okay, so first of all, let's see what are the meaning of the code here. So class CBE, what does this tell you? It tells you the CBE, this data set looks what is the class for this one? So it's a data frame, okay. And now we need to take a look of the first 5 data entry in this data frame. This will be it, right? So chocolate's production is 1,451 in the first period. Second period is 2,137, and the third period is 2,477, right? Okay. You just have to get to know the data, and now we want to plot the time series. But this is interesting here. So one of the most important things in this lecture or in time series analysis is you are going to use the TS function. So TS function in R to transform your data into a time series data set. Okay, so if you didn't do this one, a lot of the time you cannot plot out, or a lot of time you cannot run the default time series function. So this is important. We want to reclassify the data set into the time series data. Okay, a little bit. Okay, so now I named this one as chocolate, and I want to get all the variable from the first column. So let's see what chalk TS looks like here. So I have a chalk TS data set. That will be it. So I get rid of the two other variable, right? But now I already let the R know that this is a time series data. So the first entry is supposed to be the January of the 1958, all the way to the end of the data is 1990s to December. Okay, and then just plot it. Okay, and if you plot it, this will looks like this, a little bit ugly. Okay, and then you need to plot the aggregate annual series in a box plot. So there's a function called aggregate in R, and you could just simply run it. Okay. What does it mean? It means you just look at the average, right? So the average of each year. So aggregate the chalk TS divided by 12. So you add up each year's data and divide it by 12. And that is your yearly average of your chocolate production, right? So let's see. So let's see this data set. What does it look like? It looks like this. So what does it mean? Now the units of the time series data is not to the month right now. You aggregate it and becomes the annual data, right? So now your observation becomes less. Okay, so your original observation, how many you have? Let's see. Originally you have 396. So it's here. You have 396 entry observation in your data set. Since now you aggregate each year, now you only have 33 years, right? So 33 times 12 months, 33 times 12, that's equal to 396. Okay, and now just plot this annual trend, right? So let's see what this looks like. Okay, and this is your average yearly production of the chocolate. And box plot is like this. That'll be it, right? So if you don't remember what's the definition of the chocolate, the circle here is the outlier, right? And kind of so the box here is the first quantile, right? And the lower this is the this one. The up is the third quantile, and the lower one is the first quantile. So this, let me Google it. Yeah. So, let me Google this definition of the box plot. Okay, so box plot means what? Means so the box is, yeah. So this is the first quantile, and this is the third quantile. This is the first quantile, and this is the third quantile. And the heavy, like the thick black line in the middle is the average. So it's the second quantile, right? And then, oh, it's the median. Yeah, so median is the second. It's the second one. And then the bar here, it's what? The bar here is the minimum and the maximum. And um, minimum's definition is quantile time minus 1.5 IQR, so interquantile range. Interquantile range means the differences between Q3 and Q1, right? So this one is Q1 minus 1.5 IQR, and this is Q3 plus 1.5 IQR, and the rest of them are the outliers. Okay, so this just give you a sense of how your yearly production in compare with other years' production. Okay. Okay, and secondly, it's decompose the series into the trend, seasonal effect, and the residual, right? Okay, so now actually a lot of the things that are very powerful could help you. So we need to load a package called forecast. Okay, so once we load it, we could decompose the chocolate series. Okay. And now I already have a new data set. It's called this. This is the decomposed one. And this is the type of the model is called multiplicative. Okay. And the same things, I could use predictive ways to decompose. So that's just the different ways to decompose the. That's just the different way to decompose the original data set. Okay, and this is the new series I have. And this is the same thing. I transform the chocolate time series data to a log chocolate time series data and use the addictive to decompose it. Okay, and now you see here in R, actually, if you type any kind of the decompose data, what would you get? You will get 3 sets of the result. So the first one is called seasonal, and the second one is called trend, and the third one is called random, right? And we will talk about this in later on. But this basically is what? Basically, this you could treat it as each of the time series process. They are composed by 3 different components. One is called the trend. Okay, and if you think about trend, what does it mean of the trend? Means the long-term trend, right? So it's like the average of all the data points you have. What about the seasonal? Seasonal here means like January's production, February's production. Do they have the similar trait inside? Okay, so like each month, they might have some of the factors that will affect the production, the amount of the production of the chocolate, right? And now we just don't know what's that, and we decompose it. And the last things that we are going to take a look is the random one. So besides trend and seasonal, the deviation from those two sums is called a random. Okay, and that will be it. So I rename the trend data like this as trend cap T, seasonal, residual, and try to plot them. Okay, residual looks like this. Okay, remainder So remainder is what? Remainder is seasonal plus trend, right? And we try to plot one by one. So here is how we get. So I got, this is my observation, okay, and this is my trend, this is my seasonal, and this is my random. Okay, and basically that will be it for uh, question number 2. Okay. All right, and I guess no questions. Right, so let's move on to the third question. What we are going to do right now is to loading the data automatically from the online data set. So here's what you have to do. You have to download the series from this website. If you click it, that will link you to the I think it's the Federal Reserve, their database, economic database. So it's called FRED, Federal Reserve Economic Database. And this is the crude oil price. Okay, so this is the database you are looking at. So you could simply just click download and load the data to R, but there are actually a better way to do so. A better way is to just use the R command, that quote month here. Okay, so what we need in the beginning, we need to run those two. First, to install this package. If you already installed this package, you just run library to call this one out, right? So I just library. I don't want to do it one more time. So okay, so that went through. Okay, so use get symbol this function. Okay, you could get the data easily. So this is how we do. Okay, and now I already have the data frame, WTI. Oh, not yet. Okay. It's here. Okay, I already have a data frame looks like this. Okay, I haven't transformed it into R style, so I couldn't type out anything. Okay, so I need to claim that this is a data frame in R, right? So run this line of the code. So now you're supposed to be able to find out the data like this. So as you can see, this is a monthly up. They update the data monthly, so it's quite up to date. Up to the May 1st, they still have the data uploaded. Okay, and deflate the series by the PPI. So now you need a second time series data. It's called PPI. So by the same token, we could use the get symbol function, and then to download this and to transfer the data into a R code, and we could run those two. So now you see I have a data set called df PPI, right? So this is the same thing too, right? So now I have the time series data all the way back to like all the way back to very early. What's the starting point? 1986, January 1st. It didn't print it out, but I actually could print it out. But it doesn't mean we don't have to, right? And what's the next? We try to deflate it by this PPI, right? So deflate means what? I use the price level index to deflate nominal terms, and that will become a real one, right? And that's something that economists always do. Okay. What else do I have to do? Okay, I have to merge them. So I merge WTI and West Texas Intermediate and the PPI together into a new data frame. Okay, you could do this or you don't have to. And um, let's just combine it into a same data set. So if you type DF, right now the two series are come together. So they merge and they will find that both data sets have the time points that include both data sets. Okay, so this will be a DF. Obtain the data frame variables named by this. Okay. All right, so next is to deflate it. Deflate it, basically we use the function like this. And this is all kinds of the calculation that we need. So this is called a pipe in R. So what does it mean pipe? Pipe means I get a subset of the data from your whole data set. And mutate function is just telling R to calculate or do some of the calculation within the data set. So what do we need to do now? Uh, we need to give the date of the data. We need to rename it, and then we deflate it. So we will get a new a real term of the data, like df real. So this is the deflated. This is a real term. Okay. No, I need to run all of it. Oh, I need to run dplyr. Okay. So packages. Dplyrs. Okay, and then to run this part. Okay, so that went through. Strange. So if you go back to the uh, answer key, the results actually here. Okay, so you will have a function looks like this, right? And then the third part is to plot both time series level and real term, provide a brief description of the variables feature, right? So um, that's how we do here. So okay, let's be a white there's no state. Cannot find information. State. I think I just pressed the wrong thing. No. Mutate. I just wrong this one. Strange. The plier is here. Hmm. Oh, so that might be the problem of my deployer. Okay. There we go. Then we went through. Okay. Sorry about that. So now I have this. I have. Okay, so now I supposed to have DFV. Okay, so this is the real WTI that I deflated by the PPI. Okay. So then the next thing is we plotted uh, plot both time series. Okay, and uh, that will be it. We plotted. Uh, so if you run this code, I don't know why my R just doesn't work right now. To save some time, if you run the code, you will get this, and this is the real term. Okay, and this is the okay, okay. And now if we want to compare two of the different series like here, all you need to do is just using the ggplot, but you don't have to do this. You just deflate it and to plot it and to combine it, and that will be it. Okay, and last but not the least is the decompose of the series again. So we're just using the decompose code, right? And this is something that we will get like the question number 2. Okay, and that pretty much is the going over of the first question. I hope this helps. So now what I'm going to do is to give you some of the idea of question uh, give you some of the idea of the problem set 2. Okay, so um, problem set 1 is just letting you to problem set 1 is just letting you to understand the idea of the R, right? So now take a look of the problem set 2. So problem set 2 is a little bit different from problem set 1. The skills that it requires, it's more like a mathematical analysis. Okay, so give me a second. Let me see if I could project my uh, iPad to iPad to my screen. So So um, take a look of the question. So uh, question 1, 2 supposed to be very easy. So Jose want me to take a look of the problem number 4. Okay. Uh, okay. So across all the questions in problem number 2, all you need to do is to understand the random variables function. Two of the equations that you need to know. The first one is this. So we call this E the expectation operator, right? So this stuff, um, if we're using the probability and statistics, this is what we get, right? The idea of the average. Okay, so if there is a parameter before it, this become like this, and we can write it as this, which will equal to this. So whenever you see a random variable, okay, so xt and yt, suppose then our random variable a, b are parameters. So next time you see this, you have to think about this. And for the same thing, this will be the case. What about a linear combination of two random variables? Okay, so all you need to do is to separate them. Okay, and the reason behind it is because the average was calculated by linear way. Right, so you could have this plus this. So this is your first moment. Okay, and sometimes we call it mean, average, right? What about a second moment? The same assumption, xt and yt are random variable. So if I times this, this will become alpha square a square variance xt. What about this? This will become this. What about the linear combination of axt plus byt and 2 times covariance of xt and yt? Right? So basically all you need to figure out this problem set is those formula, the first and second moment equation. So let's take a look of this. So, okay, so a time series problem 4. Okay, Jose want me to go over problem 4. A time series xt follow an ARMA 1, okay, we don't have to worry about this right now, but this is the combination of the autoregressive and moving average process. So ARMA 1 Okay, by definition, looks like this: xt minus zeta t minus 1 exceeding c0 plus epsilon minus 1, where epsilon, it's a white noise. Okay, so epsilon is a white noise. Epsilon minus t, of course, is a white noise, right? So white noise means it's just a random shock each period. Does not independent with the other shocks that happen in a different timing. Okay, the first one derive the first and second moment of the xt. Okay, let's see. So the first moment is supposed to be very very uh, intuitive. Oh, sorry, I didn't change to this. Right, so the first moment is supposed to be very intuitive. So you just plug expectation value in both hand side, like this, and then use the law of the distribution, like I said, right? So this is the expectation operator, and you will get what? You will get this. Uh, you will get ext minus cext minus 1. Why those two terms gone? Because they are two white noise, right? So epsilon t follow white noise. Okay, and now we know that xt is a Armar series, and you will know that this is a stationary series. So ext is equal to ext minus 1. It's equal to ext minus 2. 1 plus c ext equal to c dot. So this will become their first moment. Okay? What about the second? What about the second moment? Okay, so let's see the second moment. Can we start it from like this? Okay, xt is equal to this plus this plus this plus this. So variance xt variance. So you will have what? Oh, a bunch of the covariance here, right? So I need this first. right? Okay, and then I need a covariance between each of the pair. So let's do this first. And you will realize a lot after all, because this is not a random variable, right? So the covariance between a non-random and a random variable will simply just become 0. Okay? And the next one is to use this second term and the third term as second term and the last term. Lastly is the third term and the last one. Right? So if this is white noise, okay, this term is supposed to be 0. Okay? What about this term? We don't know yet. Right? What about this term? The last x will not depend on epsilon t, right? So this term is supposed to be 0 as well. So all we need is to find out this, 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 and this. And that's it. Okay? So let's do it. Variance xt is equal to plus sigma squared plus sigma squared plus covariance xt minus 1. Right? So this term are going to equal to this term. 1 minus. So as long as the last term, this has been solved. Somebody here? Okay. So how do we find covariance xt et or covariance xt minus 1 small minus 1? So we need to go back to the covariance formula, right? So we get here, plug in xt, oh, xt is this. And this one is 0. So this will become this. And this is actually the variance of epsilon, right? And this term is equal to 0. So E epsilon t is equal to sigma squared as well. Okay, so now we got everything we need. Now we got everything we need. Um, there's one more thing. I think I made a mistake. Um, there's a C, I believe so. Yeah, so second term, there's a C here. That's the bad thing that nobody is in the class. I have to check by myself every time. So let's see here. CXT minus 1. So actually here it's supposed to be C, and here's 2C, this. Okay, and we already know that the last term is this. So what are the second moment of this function? It's going to be like this. Okay. Oof. It's 2. Oh, last term is 2. Sorry, so here there's a 2 over here. Wait, no. There's a 2. Somewhere, where's 2? This one, 2. So the idea is just like this, you know. Okay, so I will skip the coding part right now, but the idea of the derivation it's pretty much like this. I think rest of the answer it could be found in the lecture note. Okay, and that probably will be all for today. I hope you learned it, and we will surely go over the problem set 2 after the submission. Okay, have a good night, everybody. Bye bye.